Hi, this is Mark, and welcome to another discussion. And today we're going to talk about embedded systems. Now, what are embedded systems? Embedded system on itself is a microprocessor based computer hardware system with software that is designed to perform a dedicated function, either as an independent system or as a part of the large system. As you can see here, it says that the embedded system is one that has computer hardware with software embedded in it as one of its important components, making it a special purpose computer. As you can see here, this is the software and that is actually embedded into the hardware. Now next are to show you the applications. One of the popular application is the IoT ecosystem, and that is the Internet of Things ecosystem. And to show you a graphic representation of that are these. Okay, you have here personal computers, cell phones, printers, cameras. Aside from that are for the manufacturing industries. You also have the gaming industry. Okay, this is a PlayStation and robotics. Okay, especially in the field of artificial intelligence. And another thing is automobiles. Auto automobiles. And another thing is automobiles. The applications of embedded systems include, in general, home appliances, office of automation, security, telecommunication, instrumentation, entertainment, aerospace, banking and finance, automobiles, personal, and in different embedded systems projects. To show you an example are these popular three embedded systems. The first one is the Arduino boards. This is a microcontroller based board that has no processor, AVR microcontroller with burn bootable program of Arduino, and there's no Ethernet port and separate modules to work along with the board. To show you a bigger view of that is this. So this is the Arduino board. It is an open source platform used for building electronics projects. Arduino consists of both physical programmable circuit board, often referred to as a microcontroller, and a piece of software, or IDE, which stands for Integrated Development Environment, that runs on your computer. And you use to write and upload computer code to the physical board. So another example we have for embedded system is the popular one, and that is the Raspberry Pi boards. Now this one has a processor. An example for that is this one, 1.46 64-bit quad-core ARM Cortex A53 CPU. And it has, for programming, you can boot it with the OS boot, bare metal, and you can use C, C++, and Python programming for that. Actually, it is a credit card sized computer that plugs into your TV or display, and a keyboard and a mouse. You can use it to learn coding and to build electronics projects and for many things that your desktop PC does, like spreadsheets, word processing, browsing the internet, and playing games. And another one is the Silink Zinc boards. It's same as that of the Raspberry Pi. An example of its specification is this one: more RAM capacity, faster ARM quad-core Cortex A50 processor, SDOS bootable, two-stage bootloader JTAG connection for FPGA. So these are popular examples of embedded boards. Now for the classification of embedded system, now before we go to and proceed with the classification of embedded systems, this is a figure of how embedded system is organized. An embedded system is a combination of computer hardware and software, as you can see. As with the electronic system, this requires a hardware platform and that is built in with microprocessor or microcontroller. The embedded system hardware includes elements like user interface, input-output interfaces, display and memory, etc. Generally, an embedded system comprises power supply, processor, memory, timers, serial communication ports, and system application specific circuits. For the embedded system hardware, as with any electronic system, an embedded system requires embedded system hardware is built with a microprocessor or a microcontroller, and the embedded system hardware has elements like input-output interfaces, user interfaces, memory, and the display. Usually, an embedded system consists of power supply, processor, memory, timers, serial communication ports. It should be input-output circuits, system application-specific circuits. The next one is the embedded system software. The software is written to perform a specific function, and it's typically written in high-level format, then compiled down to provide code that can be lodged with a non-volatile memory within the hardware. An embedded system software is designed to keep in view the three limits. And the three limits are availability of system memory, availability of processor speed, and when the system runs continuously, there is a need to limit power dissipation for events like stop, run, and wake up. Now, embedded system uses real-time operating system. The real-time operating system manages the application software and affords a mechanism to let the processor run. The real-time operating system is responsible for handling the hardware resources of a computer and host applications which run on the computer. The RTOS, or the real-time operating system, is especially designed to run applications with very precise timing and a high amount of reliability. For its memory, in an embedded system, there are different types of memories, and the various forms of memories are presented in the chart below. Now, these are the various forms of memory of an embedded system. We have here internal RAM at microcontroller, RAM at SoC or external RAM, internal caches at microprocessor, external RAM, chips, flash EEPROM, ROM-PROM, memory addresses at the system ports. It doesn't mean that all these types of memory are present in one device. For the processors, different processors used in embedded systems are microprocessor, DSP or digital signal processor, microcontroller, RISC or RISC processor, ASIP processor, ARM processor, and ASSP processor. Embedding a microprocessor. As you can see on the table below, these are the different streams of microprocessors used in embedded systems. Next is the table below that shows the microcontrollers used in embedded systems. Now, the next one is a very important part of the embedded system, and that is the digital signal processor. It's a very essential unit for the embedded system. Now, the DSP applications are the audio, video, multimedia, image processing, DSP modem, HDTV, and telecommunication processing systems. The different streams of DSPs used in embedded systems are given below. Now, the next part are the types of embedded systems and can be classified into different types based on performance, functional requirements, and the performance of the microcontroller. As you can see here on the figure, the embedded systems are classified into 4 categories based on their performance and functional requirements. The first one is standalone embedded systems. Next is real-time embedded systems, network embedded systems, mobile embedded systems. And embedded systems are also classified into 3 types based on the performance of the microcontroller as first one is small-scale embedded systems, next is medium-scale embedded systems, and lastly is the sophisticated embedded systems. Now for the standalone embedded systems, they do not require a host system like a computer. It works by itself and it takes the input from the input parts, either analog or digital, and processes. It also calculates and converts the data and gives the resulting data through a connected device which either controls, drives, and displays the connected devices. Examples for the standalone embedded systems are MP3 players, digital cameras, video game consoles, microwave ovens, and temperature measurement systems. Real-time embedded systems. A real-time embedded system is defined as a system which gives a required OP in a particular time. These types of embedded systems follow the time deadlines for completion of a task. Real-time embedded systems are classified into two types, such as soft and hard real-time systems. Next one is the network embedded systems. These types of embedded systems are related to a network to access the resources. The connected network can be LAN, WAN, or the internet. The connection can be any wired or wireless. This type of embedded system is the fastest growing area in the embedded system applications, and the embedded web server is a type of system wherein all embedded devices are connected to a web server and accessed and controlled by a web browser. Example for a LAN network embedded system is a home security system, wherein all sensors are connected and run on the protocol TCP/IP. Next is the mobile embedded systems. In mobile embedded systems, they are used in portable embedded devices like cell phones, mobiles, digital cameras, MP3 players, and personal digital assistants. The basic limitation of these devices is the other resources and limitation of memory. Small-scale embedded systems. These types of embedded systems are designed with a single 8 or 16-bit microcontroller that may even be activated by a battery. For developing embedded software for small-scale embedded systems, the main programming tools are an editor, assembler, cross-assembler, and integrated development environment. Medium-scale embedded systems. These types of embedded systems designed with a single or 16 or 32-bit microcontroller, RISCs or DSPs. These types of embedded systems have both hardware and software complexities. For developing embedded software for medium-scale embedded systems, the main programming tools are C, C++, Java, Visual C++, RTOS or Real-Time Operating System, Debugger, Source Code Engineering Tool, Simulator, and IDE. For sophisticated embedded systems, these types of embedded systems have enormous hardware and software complexities that may need ASIPs, IPs, PLAs, scalable or configurable processors. They are used for cutting-edge applications that need hardware and software design and components which have to assemble in the final system. So these are the types of embedded systems. To show you a quick view of applications of embedded systems, these are the following. Okay, so these are the implications of embedded systems. With this, I'd like to end this presentation. Thank you so much for your time and have a nice day.